Okay, I'm looking at page 59 now, and we're really on the home stretch as far as our organic chemistry is concerned, and Criterion 7. You're going to need to learn this, as in memorise, if you can't sort of figure it out. But alkanes undergo substitution reactions. So you do need to know the word substitution, and you need to know what it means in terms of reactions for alkanes. So let's have a look at what's going to happen. These reactions occur slowly, and we often need a catalyst. Which, for your reactions, is also called ultraviolet light. So shine a bit of light on there to give it the reacting particles more energy to get this reaction to happen. Okay, but it's still relatively slow, especially at room temperature. So what is a substitution reaction? Well, if we look at our example in the booklet, and they're all going to look much the same. What's this? What's its name? CH4. What's its name?
Methane?
Yeah, it's methane. And in our example, we're reacting it with chlorine gas. And what happens is that because this is a substitution reaction, we can substitute one of the chlorines for one of the hydrogens. And so what we end up forming is, well, if this is methane, what's this one called?
Chloromethane.
Chloromethane. Names are written in the book.
Oh.
And hydrogen chloride is our other product. But this is not organic. Why is that not an organic product? What do we need present for it to be considered an organic product? Yeah, we need a carbon in there. And there's no carbon in there, so that's not organic. So sometimes questions will say, list the organic products. So if you're asked to list the organic products, then you would need to include that one in your answer. Now that was pretty straightforward because there was really only one spot on that methane. There was only one carbon. And so if we look at a longer chain, alkane still, so what's this one's name? Pentane. And I'm going to react it with bromine. Oops, sorry. Now we actually have a couple of places where the bromine could attach. Now I could have it on an end. can't just call it bromo because
What, bromo?
there's more than.
Is it one bromo? Yeah.
Yeah, so we would number it from here because that will give it the bromo, the smallest number. Where else could that bromine end up?
Question. Since there's two, it's being reacted with two bromos, would that bromopentane, would that need to have two bromos in it as well?
Well, the other product from that is hydrogen bromide. Yeah, so we've only got one of the bromines on here. The other one.
So if you reacted it with just one, would it go in that structure or would it want to have that?
I'm not quite sure what you mean, but
Hang on.
we'll have a look at another reaction in a moment. So if it's not on an end, it could be there, for example, couldn't it? I think I know what you mean, but so what would we call that?
Two bromopentane.
Is there any other possible?
Oh, I just have a question about that. If we were, hang on, I don't know how to word it. So theoretically, you could put the bromo, like in your drawing there, you could put it on the second one from the left side. Would that be the exact same thing? Because you can count from either side.
Yes, that would be
Okay.
equivalent of putting it off on the second, because that would just mean that I've rotated and looked at
Yeah.
the molecule from the other direction.
So the maximum you can do is 1, 2, or 3.
Yeah.
Okay.
Why isn't it possible to substitute both bromos into two spots and then end up with hydrogen gas?
Well, it would be over time, but remember that this is a slow reaction, even with a catalyst. And so if we've got this product here, that I think that's what you were probably getting at, and I'll do that as my next reaction. But that's going to be even slower, isn't it? So we'll have a look at that in a moment. But this is our other possible product. And what do we call all of these possible products?
Isomers.
Isomers. What is an isomer?
Something that has the same same elements but different configuration.
Yep. So these are all isomers. They have the same molecular formula, but different what?
Structural formula.
Yeah. That's right. And yeah, so let's have a look at this other question of, well, what happens if we just react it with, say, hydrogen chloride or something like that? So what's this one's name? Okay, if these ones are slow, where we are reacting our fluorine, chlorine, and bromine, oops, then this is much slower. And if we're going to substitute the thing is, technically, we could substitute the hydrogen, not that we would, but that's going to slow our reaction down considerably, isn't it? Because if that reaction did occur, which wouldn't, it won't, our product's the same. So in effect, we haven't changed it. So we don't consider this. Because these are slow enough as they are. All right. Now, let's stop there momentarily.